Here we want to find the derivative of a product of two functions. So far we have this. The derivative of x sometimes is written as, is also denoted as f prime of x. And then we also use notation like this. This also means the derivative of f of x with respect to x. And all this type of notation, this is also the derivative of f of x with respect to x. And by definition, it means it's the limit of f of x plus delta x minus f of x divided by delta x as delta x approaches 0. And then now we want to find something like this, the derivative of a product of two functions, function f and function g. And so by definition of derivative, if we just do a derivative of f of x, then this would be the difference quotient. Here we want derivative of a product, then the difference quotient would be f of x plus delta x times g of x plus delta x, and then minus f of x times g of x. So instead of just f of x, now we have f of x times g of x. And then instead of just f of x plus delta x, now we have f of x plus delta x times g of x plus delta x, since we have a product. And so to find the derivative here, then what we're going to do is this. So in the middle right here, we are going to add f of x plus delta x, and then times g of x. And then we're going to subtract the same thing. So adding and subtracting the same thing, it means we're adding 0 to the sum. And so when we're adding 0 to something, we haven't changed anything. Negative, same thing but negative. So we added f of x plus delta x times g of x, and then we subtract f of x plus delta x times g of x. And so basically we're adding 0 to the numerator. And so that means we haven't changed anything. And then we're going to group the first term here and the second term here together. So we're going to turn this in two groups. So the first group, we're going to have the first term and then the second term. And then the second group, we're going to have the third term and the last term. If we look at these two terms, the common factor is f of x plus delta x. And so we can pull that out. And then if we looked in here, the common factor is g of x. So we have g of x here. And then now we're going to separate this. like this. So we have this group plus this group dividing by delta x, and then we just separate them with this dividing by delta x, and then this group dividing by delta x. This is the limit of a sum, then it becomes sum of limits. So this will become the limit of the first group here, and then plus the limit of the second group. So limit of a sum is just sum of limits. And then this is just a product, and so we can separate them even further. We can even rewrite this like this. And then times the limit of this. So this is a limit of a product, and so we have product of limits. And then plus and then times the limit of this without the g of x. So this is a product right here. And so now we're letting, if we let delta x approach 0, then we get x, we get f of x plus 0, which is just f of x. And then by definition, this is the derivative of g of x. That is just g prime of x. The derivative of g, by definition of derivative, is the limit is delta x approaching 0 of g of x plus delta x minus g of x divided by delta x. And then right here, the limit is with respect to delta x. There's no delta x here. And so the limit here is just g of x. There's no delta x, so we can think of this as constant as far as delta x, as far as letting delta x approaching 0 is concerned. And then this is the limit of f of x plus delta x minus f of x dividing by delta x as delta x approaches 0. And by definition, this is the derivative of f of x. So this is f prime of x. And that's the derivative of the product. And so derivative of f of x times g of x, and then it's going to be f of x times the derivative of g of x, and then plus g of x times the derivative of f of x. And we call this the product rule.